Okay, folks, we're talking about group 7 now, and just like we could explain patterns in group 1, we're going to do the same in group 7 using the same idea that it's how close the outermost electron shell is to the nucleus that affects how strong the hold is, how big the pull is from the positive nucleus on the negative electrons in the outermost shell. Now, group 7, the halogens, have all got 7 electrons in their outermost shell. Fluorine, chlorine, bromine, iodine. And those 7 electrons mean that only one more electron would be needed to complete the shell. So rather than losing electrons, group 7, when they do chemistry and make bonds, they pull an extra electron in, usually given away by a metal, to complete their outer shell. So group 7 are trying to attract an electron and pull it in to complete that outer shell and get 8 in the outermost energy level. This means that again, they all behave in a similar way. They all want to gain 1 electron to fill up their shell. But in terms of reactivity, because fluorine is the smallest atom and the distance to the outer shell is the least, fluorine has the biggest attraction between the nucleus and the outermost energy level of electrons. So this means that fluorine is the most reactive member of group 7, and as the atoms get larger and the pull of the nucleus on the outermost energy level gets smaller, they get less reactive. So the pattern is the opposite of group 1 metals. In the non-metal group 7, the most reactive is at the top of the group because they are trying to add electrons into their outer shell, and the pull from the positive nucleus is biggest when the atom is smallest. So fluorine is the most reactive member of group 7, whereas the bottom of group 1, francium, would be the most reactive member of group 1. Remember, non-metals like group 7 want to gain electrons and they become negative ions, whereas metals want to lose electrons and they become positive ions.